let me know what part you're not seeing. And also, try a calculator step on this. The calculator step for your confidence intervals, really take a good shortcut. So number one, you have to say true or false. To estimate the value of P, the population proportion of success uses the point estimate for the mean. X is your mean. It should say X bar. This is your mean. Your point estimate is your what for your proportions? Your population proportion, what's your point estimate for it? Your P hat. Your P hat is your point estimate. This is the information you find from your sample. You can't find your information about your population. So you do a sample of, say, 1,000. You have 400 over 1,000. You find your P hat. That's your point estimate that you're going to use to represent the population. Okay? Remember doing these? We said, this is your population. This is your sample. Mean, X bar. Standard deviation, standard deviation. Proportion, P hat. Because they're still using a P, they stuck a hat over it, a little sign on it. Okay, and 5 and 6 and 7, 5 and 6 and 8, actually, you just have to build your proportion, part over whole. Remember, the larger number is on the bottom. You need a proportion, a part of that. It can't be greater than 1. So N is your 4,115, X is your 2,634. Build a proportion. Go 3 decimals. And the Q hat is 1 minus your P hat. This is confusing because I know a couple of you thought this was the year 2008. This is 2008 traffic fatalities. So 800 for alcohol related, what part? Part over whole. 1,004 adults were surveyed. 151 said they wanted to get a better job. So make part over whole. Everybody okay with that? Okay. This guy is your point estimate. Because I don't know what my entire population did. I can't possibly survey my entire population. So I'm surveying a sample. And I'm making that aligned with my population. I'm making it a point estimate. Okay, number 13, as I explained yesterday, it was a little simpler than you were looking at it. They just wanted you to build the interval, given the P hat, given the margin of error. So all they wanted you to do was this piece right here. And put these into decimals. And you could write it either way, this way or this way. So you constructed a confidence interval, and your confidence interval is falling between 45 and 51%. That's where you expect to find your population proportion, based on your P hat. Okay, I know your sample proportion falls in there, so don't tell me sample. This is your inference about your population. Ladies, good? Okay, margin of error, watch that 3%. 3% is 0.03. Okay, then we get into the good stuff. Yay. We take a look at your example 5, and we found our data from example 5, and we do a confidence interval for 95 and 99. Now, what is the only difference between the 95 and the 99? ZC. ZC, look. ZC is your only difference. God bless you. This one has a much smaller one than this one. When you multiply something by a smaller number, you get a smaller answer, right? If I multiplied 4 times 2, I got 8. If I multiply 4 times 3, a larger number, I get 12. So it stands to reason that my ZC is controlling this. That comes from my level of confidence. If I want to be more confident, give me a larger margin of error. give me more wiggle room. And it's really apparent when you compare these because everything else is the same. You have the same p-hat, you have the same formulas, it's just this guy right here that's changing. So it's forcing this margin of error to be a little bit larger. So when I do this, my confidence interval is a little wider. If you make a number line, it's easier to see. Start with this one, 0.625 to 0.655. Then go to this guy. 2,1 comes 621, comes before 625. 659 comes after 655. So do you see it wider? Yes.
Put this in your calculator, and then I get.
Okay. What are you putting in?
I did like you have 1.96 and then.
Oh, you want to put it in your calc?
Yeah. Like
Yes. Put it in exactly the way you read this. 2.575. Then do your square root sign. Then do it just like you read this. This times this divided by this. Then it's 1 proportion z integral. See it, Alyssa?
Yeah.
Now, when you're doing on the black calculators, you're going to have to put a parentheses in here. But it usually closes your last one. But only add one set of parentheses in there. Well, they get rid of one, so you just have to close it. Now, if you do this in your calculator, 1 proportion z interval. You have 1 proportion only, you're using a ZC, and you're creating an interval, not a test. If you happen to see that tail with the less than, greater than, not equal to, you know you're in the wrong one. All this is going to ask for is an X, an N, and a C. That's all you really know about this. So if you did this on your calculator, go back to example 5 and take the X out of that one. And take the N out of that one. It does return you a p-hat, which is then nice to check. And I get my p-hat that I thought I would. Maybe I multiplied wrong somewhere along the line and I didn't get the right one. So check your p-hat when it comes back. Did it work for you, Alyssa?
Yeah.
Okay, good. Order of operations says it will do your square root first. And inside of here, it will do the multiply, then it will do the divide, then it will do the square root, then it will do the multiply. Order of operations will work nice on that one. Okay, so we can see as we increase your level of confidence, your confidence interval widens. You have a little bit more wiggle room. Okay, 18 says construct a 95 and a 99% confidence interval from your data in exercise 6. And you did, yes. So again, this is the part that's different. See it? If you multiply by a larger number, you expect to get a larger answer. So therefore, that's going to change your margin of error. And that's the one that you notice. This is slightly larger. This is 2.1%, that's 2.8%. Gives you a little bit more leeway. Okay? And if you're using your test, go back to exercise 6, and again, pull out the X, pull out the N. You guys good with this? Okay? We're in no hurry. I want to make sure that you have this. This is kind of like a good time to come back because we again reviewed what your margin of error does. We reviewed your confidence intervals. We reviewed that. Whose phone is that? Okay? All right. 21 says you're a travel agent and you wish to estimate within 95% confidence the proportion of vacationers who plan to travel outside of the United States in the next 12 months. You must be correct within 3%. Within. This is the key word, within. There's your margin of error. you need to find, this is what this is asking you. When it says to you, find the minimum sample space, what letter represents your sample size? N. So I gotta look for the formula that says N equals. That's the one you're gonna go to right away. Now, here's my formula. I need my p hat, my q hat, my zc, and my margin of error. If no preliminary is available, then you cut it in half. Each one shares 50-50% chance. You make it equal, because there is nothing that you could base this on. So p hat and q hat are both 0.5. For 95, your zc is 1.96. So you're going to plug everything in, and be sure that you change this to 0.03. So you're going to plug it in, and you're going to put it in your calculator exactly the way you read that. And again, the rule says round up. You need to round up to the nearest whole number. We are asking people, so we don't have a portion of a person. Okay, then it turned around and it said, okay, now find me the sample size if in fact I knew from past information that 26% of them said they plan to travel out of the United States in the next 12 months. There's my P hat, there's my Q hat. This right here is what changed. Everything else stayed the same. Okay? So now you got a little bit smaller. You're a little bit more exact on your information. Oftentimes we don't know anything about the previous information. Like the first time through that somebody votes, the first time through that you're making an inference about anything, you're probably going to 50-50. And then you have information to base yourself on. And in comparing these, again, you can see that if you know the more information, you get a smaller sample size. Questions? No? All right, 24. 24 again said you wish to estimate within 97% confidence and within 3.5% of the true population, the proportion of computers that need repairs or problems by the time they are 3 years old. That would probably include mine. No. You get by the warranty, and as soon as your warranty is over, your computer's bugging. Okay, so we have no preliminary estimate. We've never looked at this before. So we give it a 50-50 chance. 50-50, 0.5. A ZC for 97, again, this is 97% in the middle. So these guys add up to 3%. Half of 3%, and flip it to a decimal before you divide it, is 0.015. Okay, that's your inverse norm. Now, let inverse norm do this. 1 minus 0.97, but this has to be in parentheses first. And then inverse norm will do the math for you, and you don't have to worry about being a decimal place off or anything. Okay, so find your ZC, which that one was a little bit different, 2.17. And then they had you compare it if you knew that 19% had problems. And then you could do your Q hat. So you can see again that your sample size is a lot smaller. Sometimes it's close depending on what your P hat and your Q hat turns out to be. If it's closer to the 50-50, you're going to get closer to your sample size. Questions? Construct a 99% confidence interval. 99, you have a z-score of 2.575. The proportion of men, now they gave you up on top, they surveyed 500 men, they surveyed 500 women for the irradiation part. The other part, the 350, was the second part of that chart with the microwave. Of those 500 men that they surveyed, 61% said that they favored the irradiation of meat, whatever that is. So, 1 minus that is 39%. Find your margin of error. Here's your margin of error formula. Then take your p-hat and build your confidence interval. If you do this in your calculator and you get your confidence interval, to get your margin of error, just subtract your p-hat from your high end. Just fill it in with zeros. So 0.056, and it turns out to be the same one. So you can use your calculator steps for your proportion intervals and just work yourself backwards. Then they wanted you to look at the proportion of women. So you went to your top, they surveyed 500 women. Of the 500 women, 44% of the 500 said they favored the irradiation of meat. And you figured out your p-hat and q-hat, your margin of error. Now you notice your margin of errors are similar. However, the way they asked the question in the next part was a little confusing. Were they equal? They have the same type of width in their intervals, but the intervals don't overlap. If we chart this guy, 0.554 to 666, here's this interval. Then we chart this one. It's going to end at 0.497, and it's going to start at 0.383. Their intervals don't overlap. Their confidence intervals don't overlap because their p-hats are not the same. So it was kind of like a weird question to ask, but their intervals are not equal because sometimes you get overlaps. Like with the presidents, with the polling, I always go back to that because that's easiest to see. Like if you have a 3% difference, sometimes they will overlap. This one, the p-hats were too far apart. They're not going to overlap. But the width of them were about the same because your margin of error was about the same. So if you answered it that way, I could understand why. Everybody okay with this? A little bit strange way to ask that last question. And we're going to have to do 26. Oops. Is this 27? This must be 27, right?
Yeah.
Okay. Sorry. 26. Okay, construct a 99% confidence interval. Again, there's your ZC. And you had to go to your chart from Generation X who used an investment professional. 24% said yes. Therefore, 76% said no out of 600. And then they had to do a different one from that chart. So your P-hat changes, your Q-hat changes, your N was the same. Good? Now, do you see a little bit of overlap in this one? This one has a little bit of overlap. Watch. Here's 0.195 to 285. This one is 252 to 348. See, this one had a little bit of overlap? A little bit of overlap in it. Not equal, but a little bit of overlap. All right, questions on this part? No? Monday we're going to start the confidence intervals for variances and standard deviations. They run a little bit different than this one does.